This is First Coast Math Clinic with Lesson 4, Scientific Notation, from Unit 10 Exponents, from our Pre-Algebra and Algebra curriculum. The goal in this video is to write numbers in scientific notation and in standard form. So what is scientific notation? Scientific notation is used to express very large or very small numbers. And scientific notation is written in the form a times 10 to the x power, where a is greater than 1 and less than 10. So let's look at a couple examples. So let's say we know the distance from Earth to the Sun is 93 million miles. So we've got a very, very large number here. And it's more practical to write this very, very large number in scientific notation rather than writing out 93 million miles. So what we're going to do is we need to find the decimal first. So the decimal is going to be all the way to the right of this number. And we need to first express that our a value between 1 and 10. So equal to 1 or greater and less than 10. So what I'm going to do is move my decimal so we get our a value between 1 and 10. So I'm going to move my decimal 1, 2, 3, 4, 5, 6, 7 place values. And that's going to be our x value. Remember the distance we move our decimal. And our a value is 9.3. So we can write this as 9.3 times 10 to the 7th power. And we've rewritten this very large number, 93 million, in scientific notation. Things I want to point out is since we moved our decimal to the left, right, we start with a very large number. We have a positive exponent. Okay, compared to our next example, the thickness of a piece of paper is 4/1000ths of an inch. So we have a very small number. So if we want to rewrite this, all right, we can move our decimal. So our decimal is here. Now we're going to move our decimal. We want our a value between 1 and 10. So we're going to move our decimal 1, 2, 3 places. Now we're moving our decimal to the right. So our value for a is going to be 4. So we can write this as 4 times 10. But since we're moving our decimal to the right, our x value, moving our decimal 1, 2, 3, is going to be -3. All right, when we move our decimal to the right, we need our x value to be negative. So our scientific notation is going to be 4 times 10 to the -3rd power. So when we start with a large number, move our decimal to the right. Our exponent is positive. When we start with a small number, move our decimal to the when we start with a large number, move our decimal to the left. We have a positive exponent. And when we start with a small number, move our decimal to the right. We have a negative exponent. Let's get into a couple examples. All right, so 1, 2, and 3, we're writing our numbers in standard form. We want to write them in scientific notation. So we know our general form is going to be a times 10 to the x power. So for number 1, we want our a value to be greater than or equal to 1 and less than 10. So let's move our decimal. We're moving our decimal to the right. So our power is going to be our x value is going to be negative. So we're going to stop right here. So we move our decimal 1, 2, 3, 4, 5, 6 place values. So x is going to be -6. And A is going to be equal to 6.83. So we can rewrite this number as 6.83 times 10 to the negative sixth. Number 2, our decimal is right here. Now we're moving our decimal to the left. So our exponent is going to be positive. So move our decimal to the left. So let's count our place values. 1, 2, 3, 4, 5, 6, 7, 8. So x is going to be equal to 8, and I'm moving my decimal until that x value is between 1 and 10, right? That's why I'm not stopping here or here, because if I stopped here, I would have 94.5. So I want to stop right here. So I've got 9.4. So my value for A is 9.453. And I'm going to round this to the nearest tenth. So looking at the 100th value, that's a 5, so it's going to round that up to 9.5. So my scientific notation value is 9.5 times 10 to the 8th. Number 3, we're moving our decimal to the right. So we're going to have a negative exponent. So let's count our place values. 1, 2, 3, 4. All right, I'm going to stop right here because at that place value, our value for A is between 1 and 10. So with it 1, 2, 3, 4. So x is going to be negative 4. And A is 5.4. So we get in scientific notation 5.4 times 10 to the negative 4th. All right, let's do a couple more examples. So for numbers 4, 5, and 6, we have our numbers already written in scientific notation. We want to express them in standard form. So for number 4, we've got 2.45 times 10 to the 4th. Well, let's look at our exponent first. So for number 4, we've got a positive exponent. So we want to, when we rewrite this number, we want to make this number larger. So to do that, we need to move our decimal to the right. So if our exponent is positive, we're going to move our decimal place to the right to make our number larger. So I've got 2.45. My exponent is 4, so I'm going to move my decimal point 4 places. 1, 2, 3, 4. I can fill in with some zeros. And I get 24,500 as my number in standard notation. Compare that to number 5, where my exponent here is negative. So I want to make my exponent, or my number, smaller. So I'm going to move my decimal to the left. So we're starting with 9.5. So let's move to the left 3 place values. 1, 2, 3, and then fill in with zeros. So this is going to be 0.0095 as our answer. And then number 6, our exponent here is a positive 5. So our number is going to be getting larger. So we're going to be moving our decimal to the right. $7.61. Let's move that 5 units to the right, or 5 place values to the right. 1, 2, 3, 4, 5. Fill with some zeros. And we get 761,000. All right, let's do a few more examples where we do some multiplication and division examples with scientific notation. All right, so for number 7 and 8, we're doing some multiplication in scientific notation. So for number 7, we've got 65,000 times 3,400,000,000. So what I want to do is write these numbers in scientific notation first, and then do some multiplication. And we've got to remember our properties of exponents when we do that. When we do our multiplication. So let's first write these numbers in scientific notation, and then we'll review our exponent properties. So 65,000, our decimal is right here. We want to make this number, we're going to move our decimal to the left. So we're going to move it 1, 2, 3, 4. So x is equal to 4. So we're going to get 6.5 times 10 to the 4th. And then our decimal's right here. So we're going to move our decimal 1, 2, 3, 4, 5, 6, 7, 8, 9. So x is equal to 9. We're going to get 3.4 times 10 to the 9th. Now what we're going to do is we've got our values for A, 6.5 and 3.4. And then we've got our base 10s here. So what we're going to do is multiply those corresponding values. So we can do 6.5 times 3.4, and then 10 to the 4th times 10 to the 9th. 6.5 times 3.4 gives me 22.1. And if you remember our multiplication properties, product properties, when we multiply the bases, if our bases are the same, what we have to do is add our exponents. So we'll get 10 to the 13th. So we got 22.1 times 10 to the 13th. But look at our A value now. What's happened here? We realize that A value, 22.1, is not in between 1 and 10. So we've got to do a little bit of manipulation to make it between 10 and 1, or 1 and 10. So let's move our decimal point 1 place to the left. So we're going to get 2.21 times 10. Since we moved our decimal point 1 additional place value to go from 22.1 to 2.21, we have to account for that with our exponent here of 13. So we've got to add 1 to that 13. So it's going to become 10 to the 14th power. So our answer here, 2.21 times 10 to the 14th. Since we moved our decimal point to the left, we're going to increase our exponent by 1, and we get 2.21 times 10 to the 14th. Number 8, it's already in scientific notation for us, so we can just group together our A values. 6.5 times 2, 10 to the 6th times 10 to the 4th. So 10.6 times 2 is going to give us 13 times 10 to the 10th. Okay, same problem though. Our A value is not between 1 and 10, so our decimal is right here. So we've got to move that decimal point 1 place to the left. Since we're moving our decimal point to the left one place, we've got to increase our exponent. So our exponent's going to go from 10 to 11. So our new a value is 1.3 times 10, and then that exponent goes from 10 to 11. All right, let's get into a couple of examples where we do some division with scientific notation. So numbers 9 and 10, we're doing some division. So for number 9, let's start by rewriting our numbers in scientific notation. So for number 9, let's start with our numerator. We're going to move our decimal 1, 2, 3, 4, 5, 6, 7, 8 place values. So x is going to be -8 because we're moving our decimal to the right. And then for your denominator, we're going to move our decimal 1, 2 place values, and x is going to be +2 because we're moving our decimal to the left. So we've got two different signs here. So let's rewrite this. We should have in our numerator 3.48 times 10 to the -8th over 8.7 times 10 to the 2nd. So again, we moved our decimal place. So our a value is between 1 and 10. And then our x value, our exponent, is just the distance we moved our exponent, our decimal. And if we move to the right, our exponent is negative. If we move our decimal to the left, our exponent is positive. So let's do some division now. So I can start by dividing out my a values, 3.48 divided by 8.7, and that's going to give me 0.4. And if you remember our quotient property, if we're dividing our bases, we can subtract our exponents. So this is going to be 10 to the -8 minus 2 power. So it's going to be 0.4 times 10 to the -10th. All right, but you notice an issue here. Our a value, again, same as our multiplication problems, is not in between 1 and 10. So to adjust that, we've got to move our decimal point to the right. So to do that, we're going to get 4 times 10. Now we move our decimal point to the right, our exponent gets smaller, right? So to make our exponent smaller, we're going to go from -10 to -11. So our answer here should be 4 times 10 to the -11th. Number 10, our numbers are already in scientific notation, so we can kind of set this up. We could do 2.5 over 5 times 10 to the -3rd over 10 to the 2nd. 2.5 divided by 5 is going to give me 0.5. Dividing our bases, we can use our quotient property, so we're going to subtract our exponents. So this is going to be 10 to the -3 minus 2. So it's going to be to the -5th. But again, now we're moving our decimal point to the right because our a value is not in between 1 and 10. So we're going to get 5 times 10 to the -6. We need to decrease that exponent. So we're going to get 5 times 10 to the -6. All right, so this video was lesson 4, scientific notations. If you like this video, leave a like, comment, and subscribe. I hope these videos are helping you guys. If you want to see some additional topics made, leave the topics in the comments. Again, I hope these videos are helping you guys. First Coast Math Clinic.